the 11th of May 1997, and the then world champion of chess, Garry Kasparov, is defeated in a match by the computer Deep Blue. And for me, the take-home message of this historic event is not that computers are now better than humans at navigating the big data set that is all chess, but rather that the human-computer team is better than either one individually. Humans have intuition, computers have the ability to number crunch. They are very different things. And in order for that team to operate in the world of big data, we need big data visualization, which is what I'll be talking about. Imagine a visualization of all life on Earth, millions of species, each of which has huge amounts of information, and they're all related to a common ancestor through evolution. Well, earlier this month, the Open Tree of Life team in the States published exactly that data set, and here is the visualization that they came up with for it. It's probably not what you had in mind when I asked you to imagine just now, but it is the kind of visualization that's typically used for evolutionary projects like it. I think it falls short of selling the big data set that they've got. It doesn't show all the information, it's not intuitive, and it's not visually appealing. The problem, I think, is paper. We're still rooted in what I call the paper paradigm, a paper-based way of thinking about data visualization. Even though that visualization is on a computer screen, we feel the need to constrain ourselves so that we can press the print button any time. But that's not necessary anymore. This is an example of a fractal. It is a Mandelbrot set, in fact. And my take-home message from today is that fractals like this can be used as a way to visualize big data, breaking the paper paradigm, labeling data on this so you can zoom into it. And here's my first example. This is part of the Tree of Life. The leaves represent species, and the branches show how they are connected to one another through evolution. It's like a map, so you can zoom into areas of interest to reveal further information about it. And you can see already, zooming into the whales here, that it doesn't matter how many species we've got, or how much we know about this beaked whale, for example, there is always a place to put that, and it's very intuitive to just drill in to reveal further information. Also, the interior nodes of the tree, as they're called, showing those common ancestors. We can put as much information on those as we wish. I think the reason why this is a very intuitive visualization is because we're already evolved and are very used to exploring the real world. That's big data, and we do it by looking around and moving close to things to reveal further information about them, which is how this works. The image itself actually shows, encoded in its shape, information about the underlying data. So for instance, you see a big trunk with a small branch coming off to one side. That represents the fact that most of the species are on the trunk and only a small number on the branch. Whereas a Y shape shows equal number of species either side. But this isn't the only method. There's also this spiral-shaped fractal. This is zooming into the complete tree of life here, zooming into humans, of course, because we're self-centered creatures. We've gone past the plants and fungi already, and now we're in the animals part of the tree already. And my vision for the future here is to have a single page, a website, onto which we have information about every species on the planet. Not just wild species and fossils, but also domesticated animals and plants. The causes and cures of diseases, our pets, everything that is alive or has ever been alive can be pinned on this. So I think that realizing that could have as big an impact on the world as, for instance, Google Earth has had. And the experience of exploring it is different to an encyclopedia, where you have to know what you want to search for to find out about it, or a book where we have to go through a story that someone else decided. What about our closer relatives? Genealogy. This is a multi-billion-dollar industry across the world. People put huge amounts of time and effort into researching their genealogies, and at the end, what do they get? Most of the websites give visualizations like this, rooted in the paper paradigm. They don't scale to show the large genealogies like the one on the lower half of the screen there. How can we resolve that? Well, with fractal visualizations of genealogies, like this example of the royal family. The Queen is in the centre, but you could set any individual to be in the centre, and we now search for Alfred the Great He's born in the year 849, and he's one of the Queen's ancient ancestors. So the system is zooming in through that world, but you can explore it on your own, of course, interactively, to show where Alfred the Great is with respect to the Queen. And you can see on the top left here, when we click, it shows us all of those links between the focus, the Queen, and Alfred the Great. There are other visual styles, of course, and other famous people on there. This is Darwin. But what I think people are most interested in is getting their own family trees in here and sharing them. And this is actually part of a website that enables that. You can upload what's called a GEDCOM file, put your own family tree in there. Doesn't matter if there's millions of people in it, and some people do have that. And then you can share it. This is one addition that we've recently added, that is a zoomable timeline, enabling people to have events on their lives on each node of that genealogy to be zoomed in onto and explored. And you can have any number of these with any amount of detail once again. Final example, chess. There are 10 to the power 120 possible games of chess to play, and a couple of student projects here have come up with solutions of fractal visualizations to explore that space, which, as far as I'm aware, is not something that's been attempted before. But with fractal big data visualizations, you can do that. So finally, thank you very much for inviting me, and please do look at the websites, onezoom.org and zoompass.org. In the future, I'm hoping to build further on these ideas and include other kinds of data from computing, from medicine perhaps, from other applications. So I'll be happy to take questions later.